Hi guys, this is Dr. Manjunath Chennapugod from Anveshana Academy, Bangalore, India. Dear students, in the previous class we were discussing about diesel cycle and we have done some numerical on diesel cycle. Today I am going to solve some more numericals on diesel cycle. Okay, numerical on diesel cycle. Okay, so this is the derived equation. Okay, diesel cycle we are dealing, right? Okay, now I will move towards next problem, that is problem number 5. First I will read the problem, then I will try to solve this problem step by step. In an air standard diesel cycle, the compression ratio is 16. At the beginning of isentropic compression, the temperature is 15 degrees Celsius, pressure is 0.1 megapascal. Okay, full stop. Heat is added until the temperature at the end of the constant pressure process is 1480 degrees Celsius. Full stop. Calculate first one cutoff ratio, second one heat supplied per kg of air, the next third is cycle efficiency, the fourth parameter is mean effective pressure. This is the problem he has given, dear students. Now, so to solve this problem, what you have to do, first you need to draw the PV diagram. Okay, so PV diagram, and you have to draw the TS diagram. If you draw the PV and TS diagram, you can solve the numerical easily. Okay, so the problem is related to what? Diesel cycle or diesel engine we can call. Okay, diesel engine problem he has given. So with help of suitable equation and steps we can solve this problem. Okay, so as he has given, now try to understand the problems here now. So okay, so what all things he has given? Now he is asking, he is asking to calculate the first parameter is cutoff ratio, how much amount of heat you are going to supply, then what is the cycle efficiency, and fourth one you are going to calculate the mean effective pressure. Dear students, you can see here now, when it comes to cutoff ratio, what you require then? You require temperature ratio, then you require volume ratio. With help of these two data, you can calculate the cutoff ratio. One thing, if you want to calculate the heat supply, right? Because these are four are what? Our finding. To calculate these all four parameters, so when it we require some data. What is that? If I want to calculate the heat supply, I should know the value of specific heat. I should know the value of temperature difference. Then I can calculate the heat supply. To calculate the next parameter, to cycle efficiency, to calculate the cycle efficiency, I should know the value of what? Compression ratio. I should know the value of cutoff ratio. Similarly, when it comes to mean effective pressure, to calculate mean effective pressure, I should know the value of heat supplied and I should know the value of displacement volume. Okay. Similarly, cutoff ratio, temperature ratio, volume ratio, these all parameters are required to calculate the given fact parameters. Okay. So now to solve this, I need to follow some steps. What are the first steps? So initial first step, that is initial conditions I need to list out, and I need first what? I need to list out the initial condition. What all things he has given that I need to list out. Okay. In the problem you can see, dear students, T1 he has given, temperature he has given, that is T1, and he has given P1, that is initial pressure also he has given. Okay. Then he has given some data that T4 something if T4 or T3 he has given, maximum temperature he has given, that also I need to list out. Then next I need to calculate some other parameters. What are the other parameters? I need to calculate the compression ratio, I need to calculate the other temperatures. Then how to solve this problem? I will go with what? Step by step now. Now what is the first step? As I told, I need to list out the given data. What are things he has given? He has given compression ratio. What is that compression ratio? V1 by V2 is equal to 16 he has given. The initial temperature he has given 15 degrees Celsius. Convert it into Kelvin by adding 273. Then it will becomes what? 288 Kelvin. then pressure at the beginning, that means what, P1 he has given, that is 0.1 megapascal he has given. That means what, so it is nothing but mega means what, 10 to the 4 of 6. Then if you are taking 10 out, then what happens, 10 into 0.1, it becomes 1, then it is going to have 10 to the 4 of 5. Then when it comes to 10 to the 4 of 5, right, it is nothing but 10 to the 4 of 5 pascal is nothing but what, 1 bar. Hence we can say 0.1 megapascal is nothing but what, 1 bar. That also he has given. And he is telling that temperature at the end of the constant pressure process. That means what, after heat addition, the temperature in the cycle is, that is 1480 degrees Celsius. That is nothing but what, T3. How it is T3, that I will tell you, dear students, now. Then you can convert this into by adding to Kelvin, by adding 273. Then you are going to get 1753 Kelvin. This is the data. So now, dear students, your T3, how it is T3, you can see now. I will show them PV diagram and TS diagram. What all things he has given, that you can see here now. Okay, so what is T1? T1 he has given how much, 15 degrees Celsius. Yes, T1 is equal to 15 degrees Celsius, and he has given P1. Yes, P1 also he has given. I will write it here, that is 1 bar he has given. Fine. Then but T2 is not at all given. T2 is unknown. I will keep it as it is, but he is telling at the end of the constant pressure process, this is what, constant pressure process, from 2 to 3, end of constant pressure process is nothing but what, 3. So therefore T3 he has given, that is how much, 1480 degree Celsius he has given. So that you can see it in the TS diagram. But in the PV diagram we are going to represent only pressure versus volume, but just as shown you here, but that you can show it in TS diagram. So what is the maximum temperature? So maximum temperature is 1480 degrees Celsius after adding the heat. That is in what, constant pressure process. Okay, these all things he has given. Now what we have to do, and compression ratio also he has given, that is nothing but what, V1 by V2 he has given 60. Okay, that is also he has given. But in this he is asking to calculate, first parameter is cutoff ratio, that is rho. Second one, heat supplied, that is QS. Third parameter, cycle efficiency, that is neta. Then fourth parameter is he is asking to calculate MEP. These all things he is asking now. So now we will solve this problem step by step, that you can see here, dear students, now. Okay, fine. Now I list out the given data. First, what I will do, I will go with what, cutoff ratio. What is cutoff ratio, dear students? That I already told you, that is nothing but what, V3 by V2 is equal to what, cutoff ratio, that is represented as a rho actually. This cutoff ratio I can express in terms of temperature also. How it is that? That is nothing but what, T3 by T2. So I can calculate the cutoff ratio with the help of V3 by V2, the ratio of V3 by V2, or I can calculate the value of cutoff ratio with the ratio of what, T3 by T2. So here what I will do, instead of V3 by V2, I will try to calculate the temperatures. What temperatures, then I can calculate the cutoff ratio. Here T3 he has already given, dear students, but T2 is unknown. If once you know the value of T2, then you can easily calculate the value of what, rho actually. So because now I can write the formula here now, rho is equal to T3 by T2. To calculate rho here now, first parameter is cutoff ratio, that is rho. I need to calculate. To calculate this rho, I should know the value of what, T2, where T3 is already given. Then how to calculate T2? To calculate that T2, what I have to do then? I have to go with what? First process, that is what? 1 to 2 isentropic compression process. When it comes to isentropic compression process, we know the variation of temperature versus volume. There is a standard equation. What is the standard equation? That is T2 by T1 is equal to RC to the 4 of what? Gamma minus 1. Okay. Now, here T2 I can calculate. T2 I will take it outside. Then T2 is equal to, you can take this side, T1 into RC to the 4 of what? Gamma minus 1. Then do simplification here now. How you are going to do simplification, dear students? That you can see here now. T2 is 288 Kelvin. I will substitute in terms of Kelvin, 288. Then RC is 16. Gamma we know already for air. For air, gamma value is 1.4. That I will substitute here now. Gamma is 1.4 minus 1. Then substitute and do simplification. You are going to get the value of T2 is equal to how much? 873 Kelvin. So T2 value is 873 Kelvin, dear students. Once you know the value of T2, what you can do? You can easily calculate the what? Calculate the value of cutoff ratio, that is rho. That you can see here now. So now as I told, dear students, V2 by T2, we are having an equation. V2 by T2 is equal to V3 by T3. So therefore V3 by V2 is equal to T3 by T2. This is the equation what I am using now. So now rho is equal to what I will do. I will take, this is nothing but what? Rho, right? Rho is equal to T3 by T2. This equation I will take it here now. Rho is equal to T3 by T2. What is T3? That he has given in the problem itself. How much it is? That is 1753 Kelvin divided by 873 Kelvin. Then do simplification. You are going to get the value of rho. That rho is equal to 2. That is first finding is, our first finding is done. Next, second one, heat supplied per kg of air. Actually per kg of air means what? We have to assume whatever the air we are supplying for the diesel cycle is 1 kg. For 1 kg, how much amount of heat we are supplying, that I need to calculate. To calculate that, we are having an equation. Q is equal to M into Cp. Because M, what I am doing? I am taking 1 kg. Hence, you can neglect the M value here now. Q is equal to Q in or QS. Whatever notation you want, you can give. So, Q in or Q input is equal to Cp into T3 minus T2. What is Cp? Specific heat of air at constant pressure, that we know already. It is a constant value. That is what? Cp is equal to 1.005 kilojoules per kg Kelvin. Okay. Do simplification. Substitute the value here now. 1.005. T3 he has given already. Substitute. T2 you already calculated. Substitute and do simplify. Then you are going to get heat supplied or heat input is equal to how much? 884.4 kilojoules per kg. 884.4 kilojoules per kg heat supplied we are going to get. That is second finding is done. Then next, third finding. To calculate the third finding, that is what? Efficiency of diesel cycle. We already derived the equation, diesel cycle efficiency equation. This is the equation. So then what you have to do, dear students, that is equation, you have to substitute, you have to use this equation and you have to calculate the cycle efficiency. What is the equation? That is theta is equal to 1 minus 1 divided by gamma RC to the 4 of gamma minus 1 whole bracket. This is rho to the 4 of gamma minus 1 divided by gamma minus 1. This equation in detail I have given it in the derivation. If you have any doubts, you can go back to my video, that derivation video, you can get the things clear. Okay. Now what I will do, I will use that equation. This equation already derived. You can get the things in detail in that particular video. Okay. Now I will use that derived equation. I will substitute all the values. Rho gamma is already given, that is 1.4. RC that also is given, that is 60. There is 1.4. RC is 116. Then rho you already calculated 2. Then gamma. You know all the values. What you have to do? You have to substitute all the values. Do simplify. You are going to get the efficiency. Efficiency is equal to 61.38%. 61.38%. That is my third finding, that is cycle efficiency. Only thing is what, dear students, you have to use the derived equation. You have to substitute all the values. Once you substitute all the values, you can calculate the value of efficiency. That efficiency is the 61.38% we have already calculated. Okay. Next, last parameter, mean effective pressure. So what is mean effective pressure? When there is a cylinder, right? When there is a cylinder and piston, right, some pressure is going to act on the surface of the piston. So that is nothing but what? Effective pressure. That effective pressure I can write it here, MEP, mean effective pressure, or some authors they will denote it as a PM, mean effective pressure. To calculate that mean effective pressure, we have an equation. What is that equation? This is the equation, dear students. Whereas P1 is 1 bar that he has given in the problem. RC 16 he has given. Gamma that we know constant, that is 1.4. Then what? R again, gamma is there, rho is there. What is the rho value? We have determined already 2. Then we know all the values. Do substitute in the equation, in the mean effective pressure equation, and do simplify. At the last you are going to get mean effective pressure is equal to 6.94. Mean effective pressure is 6.94, dear students. This is what? Our last finding. Once you've done this, right? Once you've done the problem, what you have to do? You have to list out all the answers in a rectangular box. What is the first finding? Our first finding is cutoff ratio. We got the cutoff ratio is rho is equal to 2. Then we have calculated heat supplied per kg of air, that is M equal to 1 kg. Then we got the Q input is equal to 884.4 kilojoules per kg. Then cycle efficiency is 61.38%. Then mean effective pressure is 6.94 bar. And this is what? Final answers. These are what? Final answers. Sometimes in question paper they will ask, represent all values in terms of graphical representation. How to represent now? Value and performance parameter. These all are performance parameters. What is cutoff ratio? That is 2 in vertical. What is heat supplied? That is heat 84.4 kilojoules per kg. That is what is cycle efficiency? That is 61. You can mark. Then what is mean effective pressure? 6.94. This is the data here at the horizontal line, and numerical value you can get it at vertical axis. Okay, this is how to solve the numerical, dear students. I hope you understood this problem. If you have any doubt, you can contact me, dear students. Okay, dear students, here with a request to please do subscribe my channel, like and comment. Okay, and say try to support Anveshana Academy. Thank you.